So the good news is there's not too much that's going to be hectic today. We actually don't have all that much new stuff to learn. If you look at the syllabus, this is section 3.5, which we kind of already did on Monday. So basically what we're going to do today is just a bunch of examples showing how what you've already learned applies to slightly more complicated cases. There is, however, one new thing I want to teach you. So this is something that we could have learned in the sentential logic section, but we just kind of didn't get to it. There was enough to deal with already, I felt. So now we're going to introduce it here. Hopefully this shouldn't be all that mind-bending for you, but it's just one more skill we can add to our symbolization toolkit. So our quantifiers can symbolize all perfectly well and some perfectly well, but those are really quite broad, right? They don't actually give you a specific number of things. So what I want to show you today is a couple of ways to symbolize things like at least, or at most, or exactly. Okay? So, and I'm just going to do it in sentential logic, if that's okay, just to make it visually simple. So consider at least. At least one of P, Q, and R. So at least one of those things are true, is what it's saying, which is exactly equivalent to more than none of P, Q, and R. And it's compatible with more than one. So if you say at least one, that's OK if there's one that's true, or if there's two, or if there's three that's true, right? At least one is compatible with more than one. OK, so how would you symbolize this? Yeah?
Just
many ors. Yeah, a series of or statements. So that combined sentence is true if P is true, or if Q is true, or if R is true, or if P and Q are true, or if Q and R are true, or if all three of them are true. So at least one is pretty easy, yeah? OK? OK. How about at least two? This one, slightly harder. It's compatible with more than two, so all three of them could be true. In this case, it's the easiest way to symbolize this is just to think through all of the cases. This is why I chose a thing with just three possible things that we're ranging over, because now we can think through all of the possible cases that would make at least two of these things being true, true. There's not that many, actually. So like this. There's really only, well, there are four cases, but we didn't need one of them. So if P is true and Q is true, then at least two of them are true. Yeah? If P is true and R is true, at least two of them are true. Or if Q is true and R is true. There's one possible case missing there, so the case where all three of them are true. But you don't actually need that to symbolize this sentence. Because if P, Q, and R are all true, then all three of those conjuncts are true, or those disjuncts are true, right? So you didn't need to say that in order to capture the meaning of at least two, because at least two is compatible with all three, of course. Yeah? So all we've done here is just sort of, instead of, well, we've just broken down all of the possible cases where at least two comes out as true, and says, well, it's this one, or it's that one, or it's the other one. Yeah? There was originally going to be a question of this structure on the first test, but I nerfed it because I didn't teach you that yet. And I hope this looks straightforward. When I show you this, I hope it looks straightforward, but it would be hard to like figure it out on the fly on a test. So, OK, at least two. So at least one, at least two. What's at least? I didn't even put a slide for at least three, but at least three of P, Q, and R. That's just all of them, right? It's P and Q and R. Yeah? OK. OK, so that's at least. At most one of P, Q, and R. That's equivalent to the following cases. One of them is true, or none of them is true. At most one says, you know, it's not more than one. It's either one or none. Yeah? It's also equivalent to at least one of P, Q, and R are false. No? At least two of. No, that should be at least two of. Does that look right now? Okay. Okay, so how do you symbolize this one? You would symbolize it as such. And once again, look, I got the logic right, and then wrote it down wrong. So, at most one of these are true means that at least two of them are true. So we just go through all the possible scenarios where two of them are false. Sorry, at least two of them are false. So we go through all the possible scenarios where two of them are false. You could, if you wanted, add in the condition here that that R is true in this case, that P is true in this case, that Q is true in this case. But you don't, strictly speaking, need to. Yeah?
But it says at most, so isn't it also possible that none of them are true?
That's right. That's right.
So then,
oh, right. Yeah, so what we'd have to add here is or. Sorry, that's exactly right. Or all three are false. So not Q and not R and not P. Sorry. There. Does that make sense now? So either two of them are false or all three of them are false. So is that most one? Yeah.
Is there any situation where you have to lengthen it that way? Because in the previous one, where you changed it, it's sort of implied.
Yeah, that's right. That's right. So no, you don't, because if you, this is logically equivalent to the first thing I had up on the screen. It's logically equivalent. So if you assign all the possible truth values to P, Q, and R and compare how those two sentences come out, they come out exactly the same on every line. So, and that's our test for whether a symbolization is a good one. So, like, this sentence does not, like, the sentence at most one of P, Q, and R are true doesn't have the same structure as this big weird thing, right? So it's not like you're capturing the grammar of the sentence in your symbolizations. What you're capturing is the truth value of the sentence. And this has the same truth value as the first thing I put up and as at most one of P, Q, and R. So that's the test for a good symbolization. Does assignments of truth values to all the parts of it give you the same kind of structure of truth values as what you would think it would say? The meaning of the sentence, does that match the truth values you would assign given the different things in the truth tables? Okay? Yeah?
Do you always use inclusive or is there some higher level logic where exclusive or comes in?
Oh, there are definitely logics where there are exclusive or. There definitely are. There definitely are. You can give yourself exclusive or by saying not biconditional. Is that right? So, well, I mean, okay, so we can symbolize exclusive or. Let's see this. So, exclusive or P XOR Q is true, 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 false, false, true, false, true, false. So that's true. It's false in that case, true in this case, true in this case, and false in that case. And you can see that that's the same as the negated biconditional P and Q. Yeah? So this is P and Q is true, false, false, true, and then you just flip these. Yeah? So a negated biconditional is equivalent to the negation or the exclusive or. So we can do that in this system. We just don't have a simple symbol for it. Okay. Okay. So at most, we got that? How about at most 2? So at most 2 of P, Q, and R. It's compatible with 0 of them being true, 1 of them being true, and 2 of them being true. But maybe, and you could symbolize it that way, like P is true and Q and R is false, or Q is true and P and R is false, or blah, 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 blah. You could do this big, long, complicated thing. Or you could notice that that sentence is just equivalent to at least 1 of P, Q, and R are false. which is easy to symbolize. How would you symbolize at least one of P, Q, and R are false? It's just the same. So remember how we symbolize at least one of P, Q, and R are true? P or Q or R. So how do you symbolize at least one of P, Q, and R are false?
Would you just make an M between P and Q and then an or in the last letter, R?
No, because it has to be possible for any of them to be true or false. Yeah.
Just be a bunch of ors where each of them is negated.
Exactly. Not P, or not Q, or not R. And that statement is true just in case one of them is false, and therefore at least one of them is false, which is equivalent to at most two of them are true. Yeah?
But couldn't you still do like P and Q or not R?
Absolutely, absolutely. So you could do, again, we could do this in a much longer way. So if you want to, so what I mean, this symbolization is much closer to the second sentence that I said is equivalent to the first sentence. If you wanted to do the first one, you could say, P and, I'll just write it out, P and not Q and not R, or not P and Q and not R, and so on and so on. Like you get a very long string, but you could do it this way. You could explicitly describe all, so there's 4 possible cases of assigning truth values here. You could just explicitly lay out each and every case, but it's quicker and easier if you notice the equivalence between at most 2 and at least 1 is false. Yeah? Yeah?
Would that be also equal to not P and Q and R?
Yeah.
With not R and true?
Yeah. So if we had a not P and Q and R. Yeah? That just says it's not the case that all 3 are true. Good. Okay, there's one last type of case. So that was at most. We did at least, we did at most. We're going to do exactly now. Exactly one of P, Q, and R. I didn't leave this to be a mystery. I didn't do a big reveal slide here. I'll just show you the answer. In this case, I think the easiest way, unless somebody can see an easier way of symbolizing this, I think you're stuck with just explicitly describing all 3 cases where this comes out as true. Either P is true and the other 2 are false, or Q is true and the other 2 are false, or R is true and the other 2 are false. Yeah?
Does that mean that if you had many variables, like, 20 something, you'd have to describe every single case?
Yeah, this is why we don't do exactly 17. Yeah, that would be, it's possible, I believe. It's just a humongous pain in the butt. So we won't do that. I won't ever ask you to do at least, at most, or exactly anything greater than 2. Yeah? Okay, and how about exactly 2? It's just the same, except instead of negating one of them, or 2 of them, we've just negated 1. P and Q are true and R is false, or P is false and Q and R are true, or P is true and R is true and Q is false. Exactly. Okay? Okay. So the overall skill here, the general gist of this, is to think through the cases that would make the sentence true. Think through all of the, under what circumstances does this thing come out as true, and produce something logically equivalent to that. And you can do that kind of, brute force it by just completely describing every case, or in some cases, and that's always valid, that's always okay, but in some cases there are just shorter, easier ways of writing it. Noticing the equivalence between at most 2 and at least 1 is false, that kind of thing. Okay? Okay. So that was number, quantity. Okay, mostly we're just going to do some examples for the rest of the lecture. Want to just quickly remind you of these things. So quantifier negation, just recall that not for all x if fx then gx is equivalent to there exists an x such that fx and not gx. So, and not, there does not exist an x such that fx and gx is equivalent to for all x if fx then not gx. This is, so what I'd like you to notice here is, for one thing, that you can, these are exactly as good as each other. The other thing is that, notice that the existentials are typically done in terms of conjunctions, and the universals typically in terms of conditionals. When you're trying to symbolize a universal statement, it's a really good bet that it's going to be a conditional. You're going to start with a conditional. And if you're trying to symbolize an existential, it's a really good bet that it's either going to be a conjunction or a disjunction. It's weird for the, it's not impossible, but it's weird for you to symbolize an existential as a conditional or a universal as just a conjunction. Because the universal conjunction, a universal conjunction says everything in the universe has this property and that property. That's just not that common. And the existential is made trivially true by being a conditional, right? So if everything, so you say, if it's a cat, then it's fuzzy, then anything not being a cat makes that existential true, which is not what that sentence means. Okay, and I want to point out, I think I did not point out last time, that these two things are not equivalent. These sentences do not say the same thing. Not for all x if fx and gx does not say the same thing as for all x if fx then not gx. Okay, so the first one says it's not the case that all f's are g's. It's not the case that for all of these things they have the property. Right? And that's true just in case there's even one thing that has property f, but it doesn't have property g. You find one case of a thing that has f, but it doesn't have g, that first sentence is true. That's not what the second sentence is saying. The second sentence is saying all f's are not g's. So for all of the things, that's true only in case all of the things that have property f fail to have property g, do not have property g. Yeah? And that second sentence is equivalent to there doesn't exist anything with both of those properties. It's true just in case you have to be able to go through your whole universe of discourse and successfully apply that these two things never co-occur. They never happen together on the same object. Whereas this one is true just in case there's just one time. It's just, you only need one example to make this thing true. Right? It's not the case that for all versus for all, it's not the case. Okay, so don't get those confused. Those say very, very different things. Yeah? Okay, and here's another non-equivalence to just keep your eyes open for. Some blank is not versus it is not the case that something is. The first one says, yeah, there's a thing that's both f and it's not g. There's a cat that's not fuzzy. There's at least one cat in the universe that's not fuzzy. Right? Some cat is not fuzzy. Versus it's not the case that something is. So there does not exist anything that's both a cat and fuzzy. Very different claim. Okay? So keep those carefully separate in your mind as we're doing this stuff. Good with that? So I showed you two things that are equivalent and two things that are definitely not equivalent. I see people still parsing this out, so I'll give you just a sec on this. Okay. Questions about this? Is this fairly clear? The strategy that I use for dealing with this stuff is just to say, learn to say these sentences out loud. Maybe not out loud on the test, but out loud in your head. Say them part by part. There exists a thing that is x or f and is not g. And that's just claiming the existence of at least one thing. Whereas there does not exist a thing. There's nothing. There are no things such that they have both f and g. And once I've said it in my head, once I've said it in language, it sort of jumps out, and the meaning jumps out at me is clear. Okay? Okay. So let's do some examples. Let's just do some symbolization stuff. Right. You don't need to know that exclusive OR stuff. All right. All right, I'll do this just for the sake of it. In predicate logic this time, quantity. At most, or at least 2 of James, Tara, and Sam went to class. At least 2 of them did. How should we say this? Well, so how do you say James went to class? Let's start from there. So CJ, Tara went to class, CT, Sam went to class, CS. Yeah? Okay, and what quantifier do we need here? No quantifier. We do not need a quantifier here. This is not a general statement. It's not a statement about everything in the universe or the existence of something in the universe. So this is in sentential, or it's in predicate logic, but it's not a quantified statement. It's a statement about specific people. Okay? Okay, so this should be easy now. We just saw how to do this. At least 2 of these things are true. Some kind of disjunction, right? So think it through. Think through all the cases that would make this sentence true and just string them together with an OR statement. If you can't remember, if there's no short way that you can remember, just think about it that way. Think about all the cases that make it true and just say this or that or the other thing. Okay? Okay. Do you want to take 1 second and still puzzle it out? Or, okay, take 1 second and puzzle this out, and then I'll just show you. Okay. So we'll just describe the cases. CJ and CT, or CJ and CS, or CT and CS. Yeah? It's an informal notation. We could make it fancier by adding all the relevant brackets, but there you go. Okay. Good there? Yeah, question?
What about the case when all 3 go to class?
So that's, okay, good. If all 3 of them go to class, that's fine. So you could say, there's absolutely nothing wrong with saying, or CJ and CT and CS. Nothing wrong with that. That is logically equivalent to what we just wrote, however, right? So you don't, strictly speaking, need that. It's absolutely fine. You lose no marks on the test for that. However, that was kind of already implied in what we said, because if this statement is true, CJ and CT and CS, then this is true, making the whole sentence true, right? If one of the disjuncts is true, the whole sentence is true. And also this one is true, making the whole sentence true. And also this one is true, making the whole sentence true. So the sentence is definitely true. If this thing is true, then this first thing is definitely true. And that's all we need in order to symbolize it, right? We need something that is true when it's true and false when it's false, and then you're good, right? Is that good? Yeah.
Can we also go the at most one of James, Tara, and Sam did not go to class?
Okay, so that one I don't think would be the same. So so if we're symbolizing at most 1, how do we say that? So it's how do we symbolize at most 1? The exact opposite. Oh, yeah, so so we said either CJ or CT or CS, or sorry, or not CT or not CS. So that's at most 1, right? No. So not CJ and not CT, or not CJ and not CS, or not CT and not CS. Okay, But that excludes two of them. So this sentence excludes two of them going to class. So it can't be the case that two of them have gone to class. You might be tempted also to say at least one of them doesn't. So not CJ or not CT or not CS. So that's a tempting way of putting this, but it's not equivalent to at least two. Because all I've said there, so this sentence is perfectly compatible with all three of them not going to class. This sentence could be true just in case, or in the case where James, Tara, and Sam don't go to class. Yeah? So this is tempting. You say, well, at least one of them didn't, but that's not the same as saying at least two of them did. Because at least one of them didn't is also compatible. At least something is compatible with one of them, or two of them, or three of them not doing it. Whereas at least two did is only compatible with one of them not doing it. It's compatible with one of them not doing it, or all three of them going to class. Okay? Okay. Number. It is a substantial wrinkle. I might have undersold the complexity of what we're going to be learning with this stuff today, but okay. Good? Okay. What else we got? All right, so this is sort of from the, this is Logic 2010 style stuff. I think this is something very similar to this is in the exercises for this week. So, dogs and dolphins jump only if petted. Okay. Well, now this is a general statement, right? We're not just saying something about one dog or a specific dog. We're saying something about the class of dogs and dolphins, right? So I propose to symbolize this as a universal generalization about dogs and dolphins. Okay, so universal generalization, our assumption, our natural assumption is it's going to be a conditional of some sort, which means we have to now sort out what's going in the antecedent and what's going in the consequent, right? Okay, so what's the topic? The topic of the sentence goes in the antecedent. What's the topic of this sentence? Dogs and dolphins. Okay, so great. So we'll say IX and KX. No, because now what have I said the topic of the sentence is? All those things that are both a dog and a dolphin. And there's none of them, right? As far as you can tell. And science has not gone that far yet, such that we have dog dolphins. So instead of the conjunct, what do we want? We wanted the disjunction. If something is a dog or a dolphin. And it's very tempting to say and because there's an and in that sentence, right? This is something you'll just have to remember that not to make this mistake, basically. Okay, so if something is a dog or a dolphin, then they have some property. So there's our antecedent. Then they have what property? They have the property of jumping only if petted. And now our good old sentential logic symbolization skills come back. You dump them in some dark corner of your memory, and now it's time to dust them off. Only if. So jump only if petted. What comes after only if? The consequent. So petted is the consequent. That means jump is the antecedent. So X jumps. Fx, then Hx. There you go. Yeah?
Could you have the first conditional be an and?
This conditional?
Yeah, so like IX or KX, the bracket, and then FX, and then conditional HX.
Let's take a look. So the suggestion is we do this. IX or KX and FX.
That's all the antecedent of the
Right.
HX.
Then HX. Okay. Let's see. My brackets are not different enough from my I. Okay. So that says, if something is either a dolphin or a dog, and it jumps, then it was petted. That's good, right? Does that work? I think that works. And this is what you're doing right now is the equivalence of two things. So if you got one of these statements, fx, then gx, then hx, that's equivalent to if fx and gx, then hx. So the antecedent of the antecedent can just be put together into a conjunction? Yeah? Yeah?
No, can we say like for all x, ix implies hx, and for all x, kx implies hx?
Good, yeah. Yeah, so here's another way of symbolizing this. We could have just done two totally separate sentences. So for all x, ix, then fx, then hx. So if you're a dolphin, then if you jumped, then you were petted. And if you're a dog, then if you jump, then you were petted. Yeah? So we just separated out what we combined into one universal statement into two universal statements. And again, that is logically equivalent to either of the first three. So these are all logically equivalent ways of symbolizing this sentence. These are all exactly as good as each other at symbolizing the sentence that we've got. Okay? And Logic 2010 would tell you one of these are correct and one of these are a correct equivalence. And that's disturbing many people because they want to see that it's just correct. Like, I don't want an equivalent to the correct answer. I want the correct answer. But that's just misleading. It's just exactly as good. They should all just say correct. Okay? Okay, let's do another. Let's do another. Among adults, only husbands and wives are excluded from singles club. All right. Really should have written down the answer to this thing. All right. All right. Well, are we saying that there's at least one of these things, or are we saying that for all of the things that fall into this category? Is it a universe? So it's clearly a general statement. We haven't named any particular objects. So here's the decision tree. Is this a specific statement about specific objects or a general statement about classes of objects? Classes of objects, good. So we need a quantifier. And now which quantifier do we need? Are we saying that there are some of these things? Or are we saying something about all of these things? All of these things. So it's a universal generalization of some sort. So for all x, something, something, something. OK. And now what? OK, so if it's a universal generalization, again, the procedure is try to sort out what goes in the antecedent and what goes in the consequent. Separate out the topic from the thing being claimed about that topic. So among adults, something, 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 right? So for all of the adults, if x has the property f, then this thing. I guess that makes the sentence compatible with children being allowed to go into singles clubs. You can be a child bride and you're allowed to go into a singles club. It's weird, but true. OK. OK. So far we've figured out what kind of sentence this is, and we've symbolized this part. Now we have to symbolize this part. Only husbands and wives are excluded from singles clubs. Okay. Only husbands and wives are excluded from singles clubs. Well, is this equivalent to only if you're a husband or a wife, you are excluded from a single club? I think so. I think so. I think it is. Is there reason to believe that it's not? Okay. Okay, so only if husbands and wives, then they are excluded from a singles club. Okay? Only if, and then. So what comes after only if? The consequence. So that means if you're excluded from a singles club, JX, then husbands and wives. But again, there are very few objects that are both a husband and a wife. I mean, the world is changing, but so far that's a rare circumstance. So husband or a wife. Is that enough brackets? Nah, let's add one more for safety. All right. Okay. So among adults, only husbands and wives are excluded from singles clubs. Now let's read it in logic ease. For all objects, if that object is an adult, then if that object is excluded from a single club, then that object is either a husband or a wife. That sound right to you? I mean, not morally, but logically. Yeah? Yeah. Yeah. So the suggestion is we say like this. So for all x, if fx, if you're an adult, then what would we say? For all x. So this only, well, okay, so how would you symbolize it? Right, because we don't, okay, so here are the options. We can say for all x again, if jx, then hx or gx. But we've done something odd here, right? Because that, remember our scope and binding rules? You're allowed to write that the sentence is a well-formed formula. There's nothing wrong with that sentence. However, these x's are no longer bound to this quantifier. So now we've got a whole new object. So for all things, if x is an adult, then for all things whatsoever, they're excluded from a singles club only if they are a husband or a wife. And the requirement, so we use this if fx then something to narrow our scope down to adults. But that's no longer that, because these x's are now bound to this quantifier, that narrowing down of scope no longer applies. What we want in this sentence is for it to be, so what we want in this sentence is to be able to go through the universe of discourse and apply it to every named object. So we want to say, okay, James, if you're an adult, okay, James is an adult, okay, good. So if James is excluded from a singles club, then James must either be a husband or a wife. Yeah? And what makes it such that the same name gets sort of plugged into all of these is that they're all under the scope of this quantifier. So if we did this thing, then you could say, okay, James, if you're an adult, then if Sam is excluded, then Sam and Sam. And you have to be able to say for any object x, so we could say y, so instead of x, we could say y down here. So for all y, if jy, then hy or gy. But then we still don't get the narrowing down that we wanted here. So you want them all under the scope of the same quantifier. And in this case, I mean, the fact that we said only husbands and wives is kind of already covered by the universal quantifier out front. Okay? This is a good question, though. It's a good question. It's a good question because it got me to let me remind you about scope and binding. Yeah?
If we do a conjunction between fx and jx,
Yeah.
then
Yeah.
yeah.
Yeah. So the suggestion is, can we do the following? If fx and jx, then hx or gx. And that's just as good. So what we've done is just pack more into the antecedent of the first conditional. If you're an adult and you're excluded from a singles club, then you must be either a husband or a wife. Or you've got a history there. I mean, there's lots of reasons to, anyway. Yeah?
Since only husband and wives are excluded, can you say if you're not a husband and wife, then you're not excluded? Would that be equivalent?
Yeah, yeah. So if you're, how would you write that out?
Not, and then the disjunction, husband or wife, and not J.
Right, right. So good. So this is another equivalence that we can talk about. So you can flip the whole thing around and say, look, if you're not a husband, hx or gx, then it's not the case that you're fx and jx. And that's fine too. So that's in the general case. If you've got x then y, that's exactly equivalent to not y then not x. So those two sentences are in general logically equivalent. We just flip the order around and negate them both. That's exactly equivalent. So you could have said, look, if you're not a husband or a wife, then it's not the case that you're an adult and excluded from a singles club. Yeah? So that's good too. That's good too. That's good too. Yeah?
Could you, in that case, also just flip the antecedent and the consequence there? Like, would it be logically equivalent? Because if you're not excluded from the singles club, then it's not the case that you're a husband or a wife?
No, I don't think so. I don't think so. So the question is, can we do the following? Oh, oh wow. Okay. Well, this is just a mess now. All right. So the question is, can we just flip the antecedent and the consequent? So can we say for all x, if hx or gx, then fx.
Not.
Oh, hang on.
So if you're not a husband or a wife.
Ah, I see. Isn't that what we did?
Oh, no, sorry, the other. So if you're not excluded from the club, then it's not the case that you are a husband or a wife. You know what I mean? Like, so it's just flipping them?
Yeah. Okay, so if you're not excluded, then
you're not a husband or a wife.
oh, so we should say if you're not excluded and you're an adult, of course.
Yeah,
Or sorry, if you're not excluded and you're not an adult, then you're a husband or a wife.
why do you have to be not an adult?
Well, because the original sentence says among adults, so the original sentence is perfectly compatible with children who are married getting into singles clubs. This is not a conversation I expected to have this morning. Okay. 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 I want to do one more. Can we leave this aside? I'd like to do one more example because I feel like we've taxed our understanding of this deeply enough. Okay. Okay. Let's do some moralizing, shall we? So, no smoker is in jeopardy unless they inhale. Okay. So again, here's your decision tree. Are we talking about very specific objects? We're given names, or are we talking a generalization, a general statement? General statement. Are we talking about just a couple of these people, or are we talking about the whole class? The whole class. So it's a universal generalization. For all x, such that we could have, sorry, I'll do this once this way and we'll do it the other way with the existential. So for all x, if x is a smoker, mx, then is in jeopardy unless they inhale, which the unless is, of course, a disjunction. So it's not the case that they're in jeopardy or they inhale. Yeah? So this whole thing is the consequent. Okay, but you might find it just as natural or more natural to read this as there doesn't exist a thing such that they're a smoker and they're in jeopardy. Sorry, there should be X's in there. And they don't inhale. Does that scan? There's nothing that's a smoker and is in jeopardy that doesn't inhale. No, that's not right, is it? It can't be right. Oh, good, I wrote this one down. Hooray. It's one of the only ones I actually wrote down. So there does not exist a thing such that they're a smoker and that. Is it? Oh, good. Bully for me. Okay. Is it clear how that says, look, there's nothing in the world that's a smoker and they're either not inhaling or they're not inhaling and they're in jeopardy? Yeah? Yeah.
So it's not equivalent to just put the negation on inhaling on the first one?
Sorry, so
Yeah, to put the negation on inhaling rather than in jeopardy for the first.
yeah. So if you said for all x, mx, then hx or not jx?
No, just the first one exactly how it is.
Yeah.
Instead of not j, it's not x. I mean,
Oh, I just flipped those around. I did it wrong. Yeah. Sorry. Okay. Not hx or jx. I think that's okay. I think that's okay. What's that?
Because if we negate the second one, we got the first line, but it's not the same thing as the third line.
Sorry. You're saying these are the same, but not this one?
Yeah.
For all x, if mx, then you're either, well, you're either in jeopardy or you're inhaling, right? So, or you're in jeopardy, you're either in jeopardy or you're not inhaling. You're either not inhaling or you're in jeopardy. Those seem the same to me, but we are currently out of time, so we'll have to debate it another time. Okay, thanks everyone.